my lecturer and classmate. I'm Liu Qiyu, and today I would like to talk about rehabilitation engineering. What is rehabilitation engineering? It is one of the field of biomedical engineering, and this rehabilitation engineering is the use of engineering principles to develop technological solutions and devices to assist individuals with disabilities and aid the recovery of physical and cognitive functions lost because of disease or injury. First and foremost, we have rehabilitation robotics. So it is dedicated to understanding and augmenting rehabilitation through the application of robotic devices. For example, is therapy robot, which is MIT Magnus. So it helps stroke patients to reach across a tabletop if they were unable to perform the task by themselves. Next, we have virtual rehabilitation. So it can be used as an enhancement to conventional therapy for patients with conditions ranging from musculoskeletal problems to stroke-induced paralysis to cognitive deficits. So, for example, this is a simulation for musculoskeletal patients. Use virtual replicas of rehabilitation devices. Apart from that, we have physical prosthetic. So there are four types of prosthetic, which are transradial, transfemoral, transtibial, and transhumeral. So for example, a transtibial prosthesis is an artificial leg below the knee. And since the knee allows for a lot of movement without assistance, the prosthesis' primary function is to distribute the weight accordingly and provide comfort. So the patients need to be rehabilitated on walking with a transtibial prosthesis since the artificial foot usually doesn't move. Next, we have sensory prosthetics. For example, cochlear implant. So basically, a cochlear implant is a small, complex electronic device that can help to provide a sense of sound to a person who is profoundly deaf or severely hard of hearing. The implant consists of an external portion that sits behind the ear and a second portion that is surgically placed under the skin as the figure shown here. And here is the how does a cochlear implant work. And next we have brain-computer interfaces. So this brain-computer interfaces is a computer-based system that acquires brain signals, analyzes them, and translates them into commands that are relayed to an output device to carry out a desired action. So the most popular example is the Dr. Stephen Hawking, as the figure shown here. And last but not least, we have advanced kinematics, which is to analyze human motion, muscle electrophysiology, and brain activity to more accurately monitor human functions and prevent secondary injuries. In conclusion, rehabilitation engineering is one of the biomedical engineering field where the biomedical engineers apply the science and technology to improve the quality of life of an individual with these abilities and also to reduce their burden. So there are a few sub-branches of research which are rehabilitation robotics, virtual rehabilitation, physical prosthetics, sensory prosthetics, brain-computer interfaces, and advanced kinematics. Now I would like to share some self-reflection. Firstly, biomedical engineering it is a field that has lots of potential in future and it is a very young engineering course. Secondly, it is a perfect mashup of physics and biology and it is core independent of each other. And thirdly, it is a novel field of study. And last but not least, it is a very interesting course that I'm looking forward of it. And these are my references. And thank you very much and have a nice day.